Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. Today we are from the last group of the chapter 8. We'll continue to present about this chapter. Firstly, I will explain to you guys about the concept of the composite. The bulk phase or matrix accept the load over a large surface area and transfer it to the reinforcement, which being stiffer, increase the strength of the composite. There are three types of component of composite material. First one is polymer, also known as polymer matrix composite PMC. The second one is metal, and also known as metal matrix composite or MMC. And the third one is ceramic, that is also known as ceramic matrix composite or CMC.
Okay, for the second component of composite material is reinforcement. The example of reinforcement is first glass, graphite, carbon, organic, boron, ceramic and metallic. Okay, for the second component is interface. Interface is the area where the different material in the composite material coincide. Second, form an interface that is strong and favorable towards the maximum compatibility. Okay, for the second meaning of matrix. Matrix is the monolithic material into which the reinforcement is embedded and is completely continuous. This means that there is a path through the matrix to any point in the material, unlike two materials when sandwiched together. In structural application, the matrix is usually a lighter metal such as aluminium, magnesium or titanium, and provide a complete support for the reinforcement. In high temperature application, cobalt and cobalt nickel alloy matrix are common.
Next, I will explain the reinforcement. Reinforcing constitute in composite. First, provide strength. Second, heat resistance and conduction. Third, resistant to corrosion. Lastly, provide rigidity, which means must be stronger and stiff than matrix and capable of changing failure mechanism. Next, to obtain desirable properties in a composite, the applied load should be effectively transferred from the matrix to the fibers via the interface. Bonding with the matrix can be either weak van der Waals force or strong covalent bonds.
For the type of composite are classified firstly according to the matrix PMC, CMC and MMC. In addition, type of composite are classified according to the type of reinforcement or filler used. So I'll present the different matrix reinforcement and properties of composite material. The first material is metal. The reinforcement material are metal, ceramic, carbon and glass fiber. The property that has been modified are elevated temperature strength, electrical resistance and thermal stability. The second one is ceramic. The reinforcement material for ceramic are metallic, ceramic particle and fiber. The properties that has been modified are chemical resistant and thermal resistant. For the third one is glass. The reinforcement material are ceramic fibers and particles. The properties that has been modified are mechanical strength, temperature resistant, chemical resistant and thermal stability. For the last one is organic. The reinforcement materials are carbon, glass, organic fiber, glass bead, plates, ceramic particle and metal wire. The property that has been modified are anti-static, electrical resistant, EMF shielding, flexibility and wear resistant.
Okay, so I will present to you unidirectional and multidirectional laminate piles for laminate composite. Okay, for the first structure, Reinforcement is particle, composite is particulate, and the properties is isotropy. For the second picture, the reinforcement is short or chopped fibers. The composite is discontinuous fiber, and the properties is random isotropy and aligned anisotropy. For the third picture, the reinforcement is continuous fiber, and the composite is also continuous fiber, and the properties is orthotropy. For the fourth and the last diagram, the reinforcement is laminar or layers. The composite is lamina laminates, and for the properties is true thickness anisotropy, planar isotropy or anisotropy. That's all for me.
Baiklah, untuk bahan komposit dia terbagi pada 3 jenis besar yang bergantung kepada filler ataupun dia punya reinforcement, dia punya bahan pengisi ataupun bahan penguat dia. So untuk first dia iaitu particle reinforce, dia terbagi pada 2, large particle dan juga dispersion strengthened. Kedua, fiber reinforce, dia continuous align ataupun discontinuous short. Yang ketiga, structural, di mana dia menjadi laminate ataupun sandwich panel. Untuk particle composite, dia punya particle sebagai filler ataupun reinforcement, dia sebagai pengisi ataupun penguat yang dalam bentuk batang, spera, sepihan ataupun macam-macam lagi lah. Macam dalam gambar pertama, kita dapat lihat dia dalam bentuk partikel yang besar. Gambar kedua, dia terpecah-pecah, dia bentuk bahan kecil yang diperkukuhkan. Untuk fiber composite, seperti yang saya katakan tadi, dia sama ada continuous ataupun discontinuous. Untuk continuous, dia punya fiber dia sama panjang dengan dimension komponen dia. Contoh, komponen tu 1 meter, dimension dia pun 1 meter. Dia akan jadi satu baris. Dia seperti kalau tengok lantai jubin yang panjang-panjang gitu, like that. Lepas tu ada juga untuk macam kita lihat ABC, dia terpotong-potong. Macam kecuali C, sebab C tu dia tidak tersusun. Untuk yang ketiga, lamina composite, dia seperti kertas yang disusun by layer, by layer. So dia akan menebal-nebal. Thank you.
Assalamualaikum, my name is Sharil, and today I want to present my part, which is fabric of composite. And this is the composites of polymer matrix composites. Polymer matrix composite is composed of a matrix from thermoset, thermoplastic, embedded glass, carbon steel, and Kevlar fibers. So today I will present to you about the method that how to fabric a polymer matrix composite. And as you can see in the slide, there are 7 methods in it, which is hand layup method, spray up method, filament winding, pultrusion, compression, molding, vacuum bagging, wet flow methods. And each of the methods is different ways. And the wet flow methods also can be called injection. It also include injection molding or transfer molding. And for the 6th, vacuum bagging, autoclaving, it also can be called autoclaving. Okay, to the next slide. Okay, in this slide we are going to discuss about the hand layup method. As you can see, there are 2 images that I put in the slide, and the image is about hand layup method. So hand layup method involves reinforcement resin, gel coat, contact mold, and laminate. First of all, they're pouring the resin over reinforcement in the mold, and they're using the roller to densify the laminate to dispose and trap air. This is called to create a smooth surface with a polymetric composite. Okay, lastly, to the last slide. This is the last not the last method. This is the last example method that I will discuss, which is filament winding process. As you can see, the filament winding process are fibers are first impregnated with plastic resin and then wound around the plastic drum mandrel. As you can see in the image, they are using the resin impregnated fibers to wound around the drum. So that's all from us. Thank you for lending your us. Thank you very much. Assalamualaikum.